All right, guys, let's go ahead. I'm sorry to interrupt your talking. We're gonna begin class. I have just like two announcements really quick to kind of help out the school a little bit. I know you guys are a little bit older, so you guys have like a lot more, like things for yourselves to do, like extracurriculars and whatnot. Probably worrying about like trying to what is it? Get ready for college. I think like this year, I think most of you guys are like writing your letters of admission and whatnot. Um, but if you have the time, please consider maybe going to yearbook. So I think out of all my classes, you guys are the ones that are probably the busiest. So I don't know if I'm going to attract anybody to go to yearbook. But right now, our yearbook staff is like one child or one student right now. So we're in desperate need of people to create a good yearbook for this year. Okay. As well as that, if you guys are interested in traveling next year, I think Mr. Spiegelberg, he has raise your hand if you're in AP German or not AP German, just like in a German class, like a German language class. Oh, there you go. Oh, great, awesome. Yeah, I've heard good things about you in his class. Okay, so Risa, you're like the only one in his German class. But he has a trip going to Germany next summer with like students and like I think like one chaperone. I think he's asking me to go. Um, Not that that's gonna entice you guys to go, okay, if I go. But if you guys do go, he's actually opening it up to beyond just like German students now, and I think the more people he can get to go, the cheaper the trip will be. So it's a huge package. It's everything's paid for. I mean, once you pay for it, so I think you guys end up going to Germany and you like travel all over and you like take trains and like you stay at different hotels and motels, I think. So it's really fun. It's really beautiful. He showed me like the itinerary. If you guys are interested in going, I don't have a handout from him. I wish I did. But tomorrow, if you guys show up to open house, if it's like one thing you should like really show up for in your own interest, it's to go to his class to check out the details for it. So he's like putting a lot of effort into it. And I see him like, he and like I kind of talk a lot, so like I see him always emailing back and forth like between like the coordinator. So he's like he's really involved and like this is like his big personal trip. So it looks really cool and fun. Okay. Um, Make sure everyone grabbed a handout. So we're gonna start in the curriculum like right now. So grab one of each of those handouts, and then we're gonna start our warm up in like 2 seconds. So be uh, be prepared. Okay. So I'm gonna put up the document camera right now for what we're gonna do. So if you guys don't want to join yearbook, I don't know, like when you guys mention it to friends or something, just say in passing, they really need it. They really need people right now, and we only got like one person. The rumor is maybe we don't even get a yearbook because there's only one person on the staff. Hopefully, there's like one person that listens to that and is like, you know what, maybe I could join. I could help out, right? Even if you're not intending to join, just like I don't know, put it as a point of like a topic to bring up with your friends, just like something interesting, like oh crud, wait, we might not have a yearbook this year. I don't think that's gonna happen, but that raise some awareness. Okay, so one of those handouts is a warm up that you can work on with your friend, okay, like a neighbor. But I'm also going to put up another warm up that I want you guys to show me on the whiteboard. So you guys have two tasks for like the next 5 or 10 minutes, okay? So I intend that you guys to do this by 8:10, so we can get on to some lessons, okay? All right, so here's the other warm up that you're supposed to do on the board, okay? So this is a limit as x approaches 1. So we're going to go into limits, and hopefully this is a little bit of review. 2x minus 17. I want you to tell me what the limit is. If you don't know what it is, find someone that does, okay? So I want everyone now to stand up, okay? Please stand up. Yep, everybody stand up, stand up, stand up. Okay, grab the paper as well, that handout as well, and find a whiteboard space and multitask right now. Okay, so find whiteboard markers are in the back behind Ashlyn and Gabby in like the corner on that little rolling cart over there. Okay, all right, so let's get to work, guys. Go. Okay, find a whiteboard space and let's get to work. Yep, yeah, just find anybody. Just be like, just kind of slowly migrate to someone, and then a physical body, and then just start working with them. Yeah, please. All right. So always, 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 always. You don't even need to ask if there's something on the board. Just erase it. Oh, yeah. Go ahead and hey, Joseph, can you hit the light a little bit? Sean, can you hit the lights a little bit for me? Yeah. So just like maybe one or two, just so people can see the projection. Okay. All right, man. All of them's fine. Yeah. Anybody hot or cold? Anybody want me to turn on the AC or anything? If you maybe don't know how to do this, okay, feel free to look around. This is not an exam, so just like look at what other people are doing. So I want you guys to have a common culture that it's okay to look around, right? It's not weird. Walk around and ask other people too. Like, I have no idea what's going on. Help me out here. See, I like that kind of talk right there. Yeah, that's good. Yeah, that's organic, right? That's totally normal. So as long as you guys are talking, okay? Like, what? How do you do this? Oh, that's my phone. Sign in, please. Matt. Oh, don't eat it. Don't eat in here. Oh, no. Yeah, just throw it away. Yeah, throw it away or eat outside. Sorry.
I want to give it to you.
No. Yeah. Normally I would accept, but not right now. Not in the middle of class. Not in the middle of class. Don't forget to sign in. I think one or two of you guys may have forgotten to do that. So this is like a big review. Okay. So try your best. All right, really good job on the main whiteboard. You guys have nailed that warm-up. That's really good.
Mr. Weed,
Yeah?
have you seen Mean Girls?
Yeah, I have.
Okay, Teresa has a shame report.
Oh, wait, she has a what?
She has not seen. I haven't either.
Oh, you haven't?
What's wrong with this school?
And you gave me goosebumps for not seeing it, Teresa. No, I'm just kidding. You don't have to. It's an older movie now, so it's alright. But it's a cool movie, so I think you'd like it. Pretty sure most of the staff hasn't watched it either, so it's not normal. Don't drop your water on Sean's stuff, man. You're always Sean is an innocent bystander that does not deserve water on his content. Alright, don't forget, you guys also have a handout, so if you can't do one, you can do the other. Or if you can do both, you can choose to do none. No, it's good. I like what you're doing, okay? Because that means you're doing that and other people are doing something. It's just, I like seeing work, so. Because I don't think anyone's done that yet, Joseph, so. Yeah, there you go. Okay, I'll give you guys like 3 more minutes, and then we'll like review. Okay. Oh, what? Would you? Yes, I sent an email back, so you should have a response. I'm not gonna say what time, but just check. Just check your email, and you'll find that you have a class code. What's up? I think there's gonna be like 15 to 20. Oh, so considering, okay, so as you guys are working, if you guys can multitask. I don't know why I put that away. The exam, guys, next week is going to be pretty long. So really practice your practice exam, like if you can, inside out. It's like a good culmination to see what from the chapters I think was really most important. And also it's not tough, it's just tedious. So my plan, or like what I intend what's going to happen like from the past 2 years, and I don't want to change it because I think like this kind of is a not a wake up call in any way, but it's just like this is a good way to let you know what kind of class this is, like what content, like this is, if you can already tell, it's quite a step up from pre-calc and all your previous math. The test, I would say when you do it, you're not going to finish it on Monday or on the Wednesday that we meet. So my intention is any other class time I have, I can give you guys like a printout or just look up the classes that I teach. Any other time that I teach or I have, you guys can come in and begin the exam when you want. So you have multiple times to come in during the week to come in and take it. Because I think what it is you're going to take it on Wednesday. You're like, I don't have time to finish it. You can come back like on a Friday, let's say. You can even come back that turn in Friday to finish it. But it's going to take you at least 2 sessions to finish it. And plus, what I added this year was the freebie points. I don't want to say freebie points, assuming that you guys are just going to, you guys have to get 100% on this, but the unit circle too. That's a new addition to the test that I put on as well for points. So that's going to be part of the exam too. It's just to fill out the unit circle, but it's to your advantage because if you know the unit circle and it's not too hard to you, it's going to add points to your final score. Okay. I plan to curve this test as well. So these tests are going to be a little bit harder, right? So that being said, just plan ahead that Wednesday probably isn't going to be the only session that you finish it. I think I had one person finish it last year, and they had like sandbags under their eyes because they're just like, this is so daunting and exhausting. Like I don't want to mentally do this anymore. So just being upfront with you guys, okay? So practice your practice exam a lot, okay? All right, are we good so far? No? Yes or no? Okay, all right, so let's return to our desk right now, and then we're going to go ahead and go over the problems. Okay, so let me unfreeze the screen because it's frozen right now. I know, guys, I'm sorry. Like, it's a kind of scary, daunting news to hear all that stuff. Okay. Before I talk about anything, like, what is a limit, by the way? Like, what is a limit as opposed to just saying solve for this problem? What is a limit? Does anybody have any idea what the heck a limit even is? And you don't have to be academic in your description here. Yes, Stephanie, you want to go for it?
As approaches, they get closer and closer.
Yeah, I'm just asking for the number that you get on this graph, on this equation, when you kind of go on the x-axis and you approach the x value at 1. What is the y coordinate look like it's going to be? Okay. I know it's not very clear like what your idea of a limit is, as opposed to just saying, why can't I just solve the problem? But hopefully we can kind of clear up some things that you're supposed to understand about limits. All right. So let's take a look at what this could look like. Okay. This is the graph. I graphed it on Desmos. I know it's really hard to see because the truth is I zoomed out a lot, right? But if you can kind of see here, I can barely do it. Then the highlighted portion right here, I put in the actual function. This is what it looks like graphed out. And now let's kind of zoom in a little bit more to scale. Actually, yeah, this is really zoomed out. And you can kind of see if you follow along this line here, you see how the x coordinate is like in your what is it, the ordered pair, like that shows up right, as I follow along and I trace the line. That gives me all the x coordinates going from like 2.088, the x coordinate, and then the accompanying y value is like 1.0773. I want to know what the y value is approaching at 15. Okay. Oh, 1. I'm sorry about that. Yes, out the y value, or the x value one. Whoops. I may have gotten ahead of myself. So I think I saw you guys over here. You guys were working on a t-chart, right? And you guys were mapping out like all the values, and that's not a bad way of doing it. But what's the downfall of doing the t-chart? Meaning like this. Like I was like, you know what? I think my plan of attack. This is not inaccurate. This is actually really good. My plan of attack is to go from each x value, okay, and then just go down the line, like maybe like numbers close to 1, like 0, 0.5, 1, 1.5, and 2, and I want to find the numbers, and I want to plug them in and find the actual value and see what the number's approaching. Does everybody see what I'm kind of getting at? Like this could be 5, could be 5.5, this is 5.75, and this is 5.5 again, this is 5. It seems to be what's the downfall of doing it this way, this method? What would not be an advantage to doing this on the test, let's say? What's up? Yeah, it takes a long time. So did anybody else find a way to solve for this that could be a little bit faster? This is not inaccurate. This is a great way of doing this, but what could be a little bit faster that we could try out? Yeah, Gabby? That's true. That's true. What if this occurred, though, on the non-calculator section? Is there any other algebraic or mathematical way that we could do this as well? So yes, you could totally graph it and look at it too. That's a great way of doing it. I'm not saying that's wrong. That's a good way. Yes? Yes. So your first plan of attack for limits, what you want to do is just plug it in. See if you can plug it in. Okay. So then we got to do something else. That's the rest of the day. So that's pretty much the rest of this class is what do you do if you can't plug it in? But can we plug in 1 into this function and get a real number? Yeah. Let's try it out. Okay. So you can write this into your notes now. So let's do that. It's 1 cubed plus 3 times 1 squared minus 2 times 1 minus 17. And then my question is, will I get a real answer? Yes or no? Yes, it's not weird. It doesn't come out to be something undefined. It's 1. So let's do that. So I'm going to write 1 plus 3 times 1 is 1 squared is 3 minus 2 times 1 is 2. And then I subtract 17. Oh. And then what should my outcome be? Yeah, if you do the math in your head, it's negative 15. Sorry, that is not the most beautiful or very apparent and clear negative 15. Okay, But if you had to understand what that looked like on the graph, it's a little hard to see on the TI-83. But as you can kind of see, the graph is literally approaching the value of y is equal to 15. Does that make sense? That's what a limit is. It's just, what are we approaching as we get to x is equal to 1? Well, it looks like it's approaching a y value at 15, okay? And most of you guys are like, well, y is just equal to 15, Mr. Wee. That's pretty easy to understand. I'm not saying you're wrong, okay? I'm just saying that the limit has more application than just looking at what the value is there, okay? Any questions so far? Oh, and how about the other handout? This is a review on... So take a look at your handout here. Sorry, and I don't have the exact handout here, right? But let's pay attention. Your question, right there, okay? Does anybody remember like one rule that you need for limits, like to make sure like that, like the number that it's approaching? You know what? I'm not making it very clear. So I'm just going to tell you right now, okay? One of the rules is if you approach a number and you want it to be a limit, if you go from the left side, and I'm sorry, so like the way I'm pointing right now, if you go from the left side and the right side and it approaches the same number, your limit is going to be exactly that number, okay? But if my graph approaches a completely different number from the left and the right, okay, you don't have an agreed upon limit anymore. So let's take a look at this. This is a good example, okay? Let's take a look. So what are you talking about, Mr. Wee? Okay, I have no idea what's going on. You're not making any sense here, okay? So let's take a look at the f of x. Like the limit of f of x as x approaches -1 from, does anybody know what that means? This little plus sign? From the positive side. So we're coming from the right side. Does that make sense? Okay. So if we look at it here, the limit of f of x, by the way, what is the f of x? If I ask you what the f of x is, what the heck is the f of x? The function. Okay, so in this, in terms of the function, what is the function here? And I'm sorry to be really redundant and tedious, but I really want you guys to know the, yeah, well, what's up? Yeah, it's just this. It's the actual graph, okay? So when I say function, I'm talking about what y is equal to, and it gives you the actual graph, okay? So as you approach from the right, okay, from the right, what number are we approaching? What y value are we approaching as we are, yeah, just 1, right? So is that true? Oh, I didn't cover that well, but yes, right? That's true, okay? How about the next one? Is it indeed so that if you approach, I can't multitask, dang it, okay, right, well, all right, I think you guys saw the answer, but if you guys approach 0 from which side, guys? Yeah, the negative side, which would other be known as the left-hand side, right? If you approach from the left-hand side, what y value are we approaching now? Okay. Okay, so is this statement true? Are we approaching a value of 0, a y value of 0? Yes or no? Yeah, we are, right? That is true. But let me ask you now, is f of x just purely equal to 0? That's the difference. How did you know that it was not equal to 0, though? What on the graph told you that is not equal to 0? Yeah. Have you guys ever seen that before? Where like you have like an open circle and then like, what is f of x actually equal to when we're talking about when x is equal to, what is it? Yeah, when x is actually equal to 0. What is f of x equal to when x is 0? Technically. Look at the graph very carefully. Yeah. So f of x would actually be equal to 1, right? But judging from the graph, when we're approaching it from the left-hand side, we are actually approaching a limit, okay? We're actually approaching some number that is 0. Does that make sense? That's conceptually the difference between limits and what your function is actually equal to, okay? And go over here. So you can kind of see from here, from here, if we go from the right-hand side as x approaches 0, okay, what is, let me say, is f of x going to be equal to 1? Does it seem like it's approaching a value at 1 from going from the right-hand side? No. So would this be true or false? Oh, that's a big false. Okay. So there are my reasons. I'm going to give you the rest of this now, and then I'm going to kind of sum up the things that you guys should see. So please write some of this down on your handout right now. Okay. And then review this when you get home. I really don't want to go through all of them, only because your attention span is gonna go to nil. And it's nothing against you guys personally. It's just that's just normal human behavior. After a certain amount of time, I cannot listen to this person talk over and over. Okay. And I think I'll be able to tell that you guys are finished writing notes once I see everyone's like pens kind of stop moving. And then you can kind of see from my notes that D, E, and F are pretty much directly related. And then D is pretty much what I was talking about from the beginning, like when I started off this weird conversation about limits. All right, are we good so far? Okay, so if you can look at D as you're writing some like the last tidbits here. If you look on the graph, it's asking me, is the limit of f of x as x approaches from the left-hand side? Does that limit, like that number that it's approaching, I think it's approaching 0, does that match the same limit that this graph is kind of going towards, or this f of x is going towards at 0, as x approaches 0 from the right-hand side? Are they both approaching the same number? Yes or no? Yes. So that's why D is true. They're both approaching the same number. So their limits should be both 0. Does that make sense? We're both approaching a y value at 0, okay? So that's true. And then f is true because we know, oh, I'm sorry, so don't jump ahead. Then we can say this. If you're approaching from the left-hand side and you're approaching from the right-hand side the same exact number, it makes E true. F, the limit of as x approaches 0 now exists. As long as you have the same number, or like you're approaching from one side and the other side, and they're both approaching the same number, now officially that the limit of f of x with no sign next to the 0 or no sign next to the number, it does actually exist now. Okay, it's a consistent limit now. Okay, you don't have to say from the left and right anymore. If you say that, it implies that it's the same number from the left and the right. They're both approaching the same number, okay? And then F is just saying, well, what is that number that we're approaching when x is approaching 0 from both sides? It's a y value of 0, okay? Any questions so far? No? I have a few more. I'm going to give you the last few answers in the back here. So go ahead and write this down. These are just the other points, not just x is equal to 0, x is approaching 0, but x is approaching 1, x is approaching 2 from the negative side, okay? I don't know if you got my text from last week, but I did put up new videos too. Some were optional to watch, yeah. So, but the ones that were not optional, please watch, okay? Because those are things that I wanted to cover in class, but obviously I couldn't. Okay. All right, I'm gonna put that up for like about 10 more seconds, and then I'm gonna go on to some new notes, and then hopefully I'll give you some more time to just work a little bit so you can practice. All right, let's go ahead and stop there. Okay, so Okay, so let's take some notes, guys. So this is 2.1 rates of change. Rates of change and limits. The big key is going to be the limits today. We're going to talk about the limits. And let's see. First, let's talk about just what a quick limit is, like the definition. A limit, quote unquote, equals L, means that the values of a function you're evaluating of a function approach but do not necessarily do not necessarily equal. Okay, so that's kind of bad. I'm using equal as a verb, so my bad. Okay, equal some chosen instant / number value or number. Okay, so again, a limit that equals L means that the values, okay, of a function that you're evaluating approach, but they do not necessarily equal some chosen instant or number. And what they say at limit equals L, you could see this. X approaches some value C, f of x could equal L. That's what that first sentence means. This limit as x approaches some number could equal some value. Okay, so L is just literally just some number. Okay, some chosen instant or number, right? So we saw an example, and then now we're going to talk about something that so we're going to mention this. Some functions you cannot find merely with substitution. So you remember from the first example, we substituted in 1, right? And then you got negative 15.
If it's like x minus 1 and then it approaches 1, then you can't just tell on the bottom.
Yes, you said so. Stephanie, you said something about the bottom, right?
On the denominator of a fraction, and then on the bottom x minus 1. On top it's anything, and then if x approaches 1, then you can't put it in, because then you divide it by 0. You can't do that.
Let me give you an example too, besides just that, Stephanie. How about this one here? Sine of x, 2x squared minus x. So I'm going to launch into one that's already pretty complex. And I'm going to give you 2 other ones that are, I think the first one is a little bit easier to figure out, and then one's going to be a little bit tougher. But let's go through one example, okay? What is the problem with this specific problem if we use substitution? So yeah, what would you end up getting? You would end up getting, if you plugged in 0 for sine, what is the sine of 0? Does anybody recall what this?
0.
It'd be 0. And then if you plugged in 0 on the bottom, what would you end up getting?
0.
Okay, you're going to learn later that you cannot have this situation, okay? This isn't even a value. 0 divided by 0, you'd be like, anything divided by 0 is 0, right? Not this one. This is technically what we call undefined, because it won't actually give you a value. You don't, like, that won't give you any value on the actual graph. You're not going to get 0. You're going to get something else. But with a little bit of maneuvering algebraically, okay, you can get this to actually give you a real definite value for your limit, right? You actually know what value you're approaching. So one of your handouts, let's see if I have it strategically up here. Oops, this isn't the handout, but your other handout. So please take a look at your other handout. You have a few other laws on there, or like a few things to know about limits. Let me open it up really quick. Week 3, okay. And we're going to talk about, I believe this is it right here. My apologies, I should have had this up earlier. Okay. I know it's a little bit odd because you see a bald man on your handout, okay? So, anybody have any inclination to why there's a bald man? No, it's not Mr. Spiegelberg. No, it's someone else entirely. Okay, it's another professor, but I literally grabbed these from a video that I was watching quite a long time ago too. And I always thought this was really useful. Now I get to use it as an academic handout. So look at that. That's funny. Let's look at the first one really quick. Like the limit as x approaches a. So how to read this? A is just some kind of constant. And like I said before, whatever number that is, I just call it L1, okay? When you go further down, like when you go further down these screenshots here, this gives you all the things that you can do with limits. One that we're going to look at right now is this. So maybe highlight this on your handout and star it and say that that's the product rule, okay? If you have a limit that approaches some number and you have what looks like to be two different functions that you could separate because they're being multiplied to each other, you can take them out and take the limits of those products separately. Or I'm sorry, the limits of those guys that are being multiplied separately. I'm going to show you what that looks like in just a second. So this relates to this guy on the handout right here. So right now, let's just pretend in context right now, I am stuck on this problem, either in a test or some weird environment. And I just kind of just look at this and I don't want to give up on it. What things could I do to this algebraically? Does anybody see anything that I can just kind of, anything I can do? Just like nothing groundbreaking here, but is there anything on the bottom or the top that I can just be like, why not? I could take a common factor out, or I can, yeah, because both of these have x, and right? Why not? X out of 2x minus 1. Okay, and now you're still sitting there in the exam or wherever you are, okay, or in an office building, okay, let's say that you're an engineer, and you hate the fact that you're trying to approach this weird limit, okay, because this does mean something to you. Like this could mean financially, what are we looking at like 0 year? What's my limit here? And I have no value, and your calculus isn't that great, okay? So you're like, oh man, what do I do now, okay? Well, let me be your aid here, okay? I know this is kind of flimsy here, but let's go back to this rule. The one that I starred in here visually. I could separate these two as if I'm looking at two things that are being multiplied to each other. Let's say f of x and g of x, and I could take the limits of these two. Meaning this, if I look carefully at the bottom, right, it's almost as if you have two different denominators, and you can rewrite this as sine of x over x times the sine of x over 2x minus 1. Hey guys, can we kind of refrain from side talks for the time being when we're kind of going through the notes, okay? And then once I separate those out, I told you too that these L's, I know it's kind of weird, but these L's means you could take the limit of these guys individually. So I could take the limit as x approaches 0 for both of these guys. I know I don't have that much space, but let's say x approaches 0. Let's take a look at the second one, all right? The limit as x approaches 0 for this guy. Remember, I could still technically divide by 0. I just can't have 0 divided by 0. That's a no-no, okay? What is the limit of this, or what is the value going to be if I just plugged in 0? If I just plugged in 0, what would it be? If I plugged in 0 at the top, sine of 0, that would give me 0, right? But look at this. 2 times 0 on the bottom. That's not too bad. 0 over 2 times 0 minus 1, that would just be negative 1. That's an okay answer. That's perfectly fine, because you'll end up getting 0 divided by negative 1, okay? Like this would be 0 divided by negative 1, and that's fine. 0 divided by any number is 0, okay? So that's okay. That's handy dandy okay, okay? All right. Times 0, right? Why is it that I left this blank, though? Anybody see a problem with this guy here? Because you would think if I put in this guy and I plugged in 0 divided by... This would just be sine of 0, which is 0 divided by 0. I'm in that situation again, okay? I see gray right now. You're like, oh, this, I don't like this. I don't like where this is going. Maybe you're not like that, where that is mentally. I'm just going visually by what I think you're going, or you're mentally at right now. I might be completely off base here, okay? But let's back up. Back up! Okay, whoops, back up. Okay. In your book, okay, on page 60, you can write this down, okay? In your book on page 60. Okay, I'm getting mad now. Okay, I'm getting a little crazy, okay? Oh, well, I'm getting mad because this camera can't extend this far. Oh, there we are. Okay, okie dokie. What does that say to you right there? What is the limit as x approaches 0 of sine of x over x in this one peculiar situation? I know. I see Emily. Emily, you're mouthing it. It's equal to 1. It's equal to 1, okay? This is one unique case where you do have a actual whole value that breaks your expectation. I believe there's a proof for this, but for the interest of time, I'm not going to go over that. That will add another 20 minutes of me yabbering and yabbering. I don't want to put you through that, okay? You're already going to get me yabbering later on today, so why yabber more, right? But in this case, if you don't know, you can put maybe I don't know, just a note to yourself. This is how I write a note to myself. If this doesn't make any sense to you when you look back at this, like, what the heck was going on in class? Don't do this, but make a note to yourself that this is on page 60 of section 2.1, or just page 60, that this is something unique. This is not something that's supposed to normally happen. And there is a proof. I can make a video proof, or I can post up a video proof of why this is, okay? So now we have 1 times 0, and then what would that finally give me? A limit of what value? Just 0. So there we are. You don't have to write this again, but the limit as x approaches 0 of this weird thing, okay, 2x squared minus x, we actually found a real value. That actually makes sense. It's just 0, okay? All right. I'm going to give you 2 problems, and you're to go on the board and try to figure it out. The first one isn't exactly like what I just gave you, but I have a weird feeling that you might figure this out on your own, because you guys are pretty bright, and you guys are very creative. Okay. X squared minus 1. So that's the first one. I want you to figure that one out with your friends, okay? And the other one will be a little more challenging, but it'll be a little bit more like what I just did up here. X. 2 problems. You guys have 10 to 15 minutes to solve this, okay? So please find a place on the whiteboard and try to solve for these 2, okay? I'll give you guys a few minutes on your own, and I'm going to walk around and help you guys out. Good luck! Good luck! Good luck! Sorry. Stephanie, I'm going to give you some more space so you don't trip, okay? So just make sure you don't trip, okay?
Oh, yeah.
Yes.
So when you did this earlier, like I understand that you showed us that, like this is like okay, but why did it have
Sine squared of over 4. Wait. Give me 1 sec. I made a mistake on my notes here, actually. So let's see. Oh, dear. No, you're right. No, I'm a goof. Guys, go back up 1 second. Mr. Lee made a goof. Okay. Ashlyn totally called me out on this. You have every right to as well. Okay? I'm not saying that in a weird negative inflection tone. Okay, guys, go back please to your notes really briefly. Okay, I made a mistake. If you have whiteout, you might want to white this out. If you don't, I'm so sorry. I just screwed up your notes, your beautiful handwritten notes. When I separated this out, guys, I was not like you guys. Some of you guys were probably looking at this the whole time and being really nice to me. Like, I'll just let him talk, but I don't understand what happened. Okay. Remember when I separated this out into this? I separated sine x over x 2x minus 1. I have the limit of sine of x over x, right? This was supposed to be not sine of x. I don't know why I wrote that twice. It's just supposed to be 1. Does that make sense now? Does that make a little bit better sense? So you'll end up having this. So fix your notes, guys. I do not want to give you bad math, which I just did. So your limit actually should have been -1. And once you fix that, you can go back to your question, okay? If you don't know what happened, you feel free to stay at your desk and like, what just happened? What did he just tell me? What did he do to me? What bad math did he just teach me?
Huh? Can I see the other question?
Oh, okay, sure, yes. Yeah. You are. Okay, and then I'm going to go back to the original question now, or the question that was going to tell you.
Yeah, so it's 1 times 1 over 1. Because it's 0 plus 1 is 1. Oh, is it, wait, is the limit was, oh, it was to 1, and that was to 0.
Alright, I'm going to go around and help you guys. Where are you guys? Where are you?
That was the easy one. I like that one. I'm a fan. Okay.
You guys take this.
Okay, so
Alright, go on to the next one. Wait, you had,
I like the limits.
process that, right? Yeah, 1 over x.
This one's fun. Great, may I ask why you have lots of certain factors?
Oh, I see. So you separate it out.
That's your choice food? Yeah. Nice. Actually, Sabrina got me this for birthday. What a friend. I know. That was a real present. Right? Actually, really excited. Those are also the best. Yes, you're just, wow, you know. It is. Yeah. I mean, she brought me that and Cheerios and her letters. The food that I get at school all the time. What more can you want? Very little. That's just. So yeah, those are kind of perfect. Yeah, that's been great.
So you separate this out
Very tired, and I got those filled off with seeing more like
times 1 over x.
yeah, it's great. Because I'm also vegan, I can eat oysters.
I think my
Or
math.
the things that you usually eat with oyster crackers, but you don't eat them. They're great.
So solve for this.
It tastes like flour. No. Wait, really? They got garlic. Yeah. Well, the ones that they sell at Trader Joe's are here, the ones that they sell there, which is great.
Alright, I'm still gonna go around and help you guys. Okay.
Oh, they're so good. That's all I do.
Okay, good.
My mom never buys it. And then we get sick. Like, oh, I'll get you something.
I can help this.
We get better. That's so sad.
I don't even actually know.
Devastating.
Yeah,
that's
separate
so good. Like, until you
Sine of x times
I just solved it using a famous Sorry, Stephanie.
Okay, one more minute, guys. All right, go ahead and return back to your desk. Let me go over this really quick. Oh dear, my favorite pen. Oh, there it is. All right, so let's go ahead and look at the first one. What did you guys separate this out into? If we did the product rule, or the what I call the product rule right now, what two things did you separate this into? Or actually, what was the first thing you did? I don't actually care about separating out into anything. What did you guys first do? Yeah, so the first one, I'm sorry, the denominator, you could have factored out into two binomials, which is x plus 1 times x minus 1. You could have done this multiple ways, okay? One way is, in case you were lazy, you're just like, nah, I think this just cancels out, Mr. Wee. So, and that just becomes 1. You could have done that. But if we're going to be consistent with the way I showed you, which I think a lot of you guys were actually really respectfully doing, actually, that was actually really nice of you guys, for those that you did. I would have just done this. I would have been like, oh, well, you just do that, and then you get the limit of x approaches 1 over x plus 1, Mr. Wheat, and I'm done, okay? And that's fine. You could have done that. You would have added in the 1 on the bottom, and then you could have got 1 over 2. That's fine. I actually really like that method. But if some of you guys were trying to make this work with what I just showed you, then you can do that too. I think that's actually really nice of you to do that. It could have been x minus 1 over x minus 1 times the limit, sorry, x approaches 1, as the limit as x approaches 1 of 1 over x plus 1. Because again, you get that same effect. X minus 1 over x minus 1 will still cancel out if you separate it out this way. And then you end up getting the limit as x approaches 1 at the constant value of 1 times, and then if we plugged in 1 into this statement here, it's 1 over x plus 1, that's 1 half. That's because that's just 1 plus 1, right? The question is, this you might not know. Actually, what is the limit of a constant value? Does anybody remember that? Can I borrow your handout? One of your not yeah with the bald person. Okay. Thank you so much, Teresa. Okay. I believe that's let me see where it is. That's one of the rules here. I would hope that he put the rule here, but I guess he didn't. Okay. This is a slightly flawed. Very flawed. Okay, sorry about that. This is a slightly flawed handout. It should have been on there. Okay. Yeah, I mean, if I told you y is equal to 1, right? Just like you don't have to draw this down. Okay. Oh, I'm being clumsy. Right. Sorry about that. Y is equal to 1. What graph would we imagine seeing at y is equal to 1? A straight line going like this, right? That'd be our line. So if we approach x equals 1, what is our y value approaching? 1. How about if we approach the x value of 2? What is our y value approaching? So you guys kind of get the gist of this? If you guys have a limit of a constant value, your limit is going to be that constant value. Just be 1. Okay. So again, whatever your limit is, if it's a constant, your limit is just that number. Okay. There you guys go. Okay. The second one was, I think, a little trickier. I'll write this in black for it being so grim and being so... No, I'm just kidding. Sine squared of x over x. Okay. What did you guys do for the second one? I am stuck on this problem. Where could we begin? Anybody have any suggestions here besides Stephanie? Because I know Stephanie, you always have a... No? No one wants to start this out? Yes, great. Okay, so we have sine of x squared, and we know that that separates into sine of x times sine of x over x. I'll just write the limit. I'm not going to say what it approaches for now. I think we know what it approaches right now. And then I could separate that into 2 different limits. One is sine of x over x times the limit of just sine of x. Does anybody recall what this is? This unique situation where it should be not possible. What is the limit as x approaches? It's just 1. Yeah. So we know that. That's a peculiar situation. The limit as x approaches 0 as for the function of sine of x is just... Oh, I think it's 1, isn't it? No? Is it 0? Forget. The sine of x. Oh, it is 0. It is 0. Yes, it is 0. My apologies. So your final answer is going to be 0. Okay? But it's a good solid 0. It's not 0 divided by 0 or 0 times infinity. Okay? Any questions so far? All right. We're going to continue on our notes with 2-2. And then that's going to be the final section. So has anybody already finished these sections for homework already? Yeah? Have you? Yeah, because I think you went by the pacing. Yes? Yes? Yeah. Yeah, if you went by the pacing, you should have been done by now. But it's okay if you didn't, right? So I think for you, Sarah, it might be a little bit redundant. Like, I'm just here for formality, but okay. I'll just see what he has to say. Okay. So I thank you for still coming to class. Okay, so this is 2-2. Limits involving infinity. And then maybe not on your actual notes, maybe on like a scratch piece of paper on the back of a paper. Try this one. I know it's scary because I didn't really talk about x going to infinity, okay? But you can say as x approaches a positive number all the way out there, right? On the x-axis, you're basically approaching infinity, okay? By the way, is infinity a number? No. What is it then? How would you describe it? All of the numbers, or I just say it's like a concept, right? I don't know what else you could kind of say that, where it has no value, it's just a concept. Like if you told someone I have infinite amount of money, that's a vague number, but you can tell he makes, or that person makes a ton of money, okay? So as x approaches infinity, you have 1 minus the cosine of x over x squared. Try to figure this out. Try to figure out a solid value for this. I'll give you like a few minutes. No, don't do it on the whiteboard. Just try to solve this, okay? No weird competition. I mean, if you don't know, just like, hey, you can ask your neighbor, do you know what you could do? Or if you guys are both in a blunder, I don't know what's going on. What you can do, I don't know. I don't know, for some people, they'd be like, what, you want to see what I can do? Okay, it's fine. Treat it like that. It's good. It's fine, fair enough. Okay, some of you guys are using your calculator. That's perfectly fine. This is a Anybody have a solution? I'm going to stop you guys in like half a minute, so just try your best. All right, I'm going to go ahead and stop you guys. It's perfectly okay if you did not get this, all right? Because what I'm trying to segue into is if you cannot find a technique to solve for this, I will provide you one. It is called the squeeze theorem. So hopefully I can explain to you what this means. The squeeze theorem to find the limits. Squeeze theorem to find the limits. Let me first show you just the math. In the math, you're going to be like, I'm just kind of writing down these notes. I really don't know exactly what's going on, but that's good. And then it'll make you kind of critically think, what the heck is going on? And then I can provide you the context, and then you'll be like, oh, all right, that's cool. If I just tell you it right away, everything from the start, you might be like, all right, that's great. All right, that's good. Okay, cool. Okay, passive learning isn't as good as active learning. So this is how I'm going to make you actively learn. Let's just first look at the if you could just look at the trigonometric function, cosine of x, okay? Let's just look at the cosine of x briefly. And let's look at its range. Does anybody remember what the cosine of x looks like? Can you do it with your hands? Like what does it look like? Yeah, it's kind of squiggles, nice little squiggles. Okay. That being said, if you know it's squiggling up and down or oscillating, that's a nice dynamic verb to describe its behavior. What is its range? Meaning, what is the highest and lowest x values I expect to see at a state? Well, let's see, Stephanie. I don't know that for sure, right? I'm not trying to insult your intelligence. I'm sorry. That's not what I meant. I have no intentions of being that way. I'm sorry. So you go up here. It looks like it tops out at what y value? Yeah, like 1. And it bottoms out at, no matter how many times I oscillate, is that behavior ever going to change? Not for this particular graph, okay? So the way I would write this range, I know there's many ways to write this range. So we're still looking at this example up here, okay? So this is the function f of x, and it is between, it is less than, all these values are going to be less than 1, but it's always going to be greater than, you're right. Oh, I'm so sorry. Because it does, yeah, it does top out at 1. It actually touches 1, right? It doesn't approach 1, but it actually hits 1, right? Very good. Here's the technique to using squeeze theorem, and then I will explain what the heck squeeze theorem is, okay? We're going to make this guy look like this guy up here. So I'm going to manipulate my equation in the middle, and whatever I do to this guy here, I'm going to have to apply to these two numbers out here. So, okay, stand back, okay? Just take my word for it for now, right? So one step that I can do is I could subtract, or let's see, you know what? Yeah, let's multiply this by -1. Wow, that's really good. Okay, so let's multiply this by -1. Because it looks like it's 1 minus cosine of x, right? Let's multiply this guy by -1. Let's multiply this guy by -1, okay? So let's see, I'm going to end up having negative cosine of x. And the numbers out here are going to be now +1, and this is going to be -1. What's going to happen to my signs? Does anybody remember that? Yeah, they will. They will. They will totally flip. Good call. Okay. So we're one step looking like this, or we're one step closer to looking like our actual start here. which is what we want to get to. What else can I do to get this to look more like this guy? What can I do algebraically? I could also add 1 to every guy. And again, I know you're asking, where is this really going? I don't really know. Oh, sorry, that's minus cosine of x. And then this is going to be 0 now, which is perfectly fine. And what's the last step in order to make this middle function look like the function that we have up here? Yeah, thank you very much, Ashlyn. You divide each side by x squared. So whatever I do to the middle guy, I got to apply to both of the numbers on the outside. So now I'm left with this weird amalgamation of what's going on here, okay? And in fact, these are now sort of functions. So actually, yeah, I'm going to leave it like that. These are weird kind of functions here, okay? And we're trying to find the limit as x approaches 0. So let me back up a second, and let's put this on Desmos really quick. Oh, whoops, I forgot to tell you guys too. The solutions for chapter 2 are now up, in case you didn't get the text message yesterday. But it's on Google Classroom. If you don't have the Google Classroom code, please let me know. I don't know what's going on, so I'm going to have to close this for now. I think it's just really slow. Oh, there it is. Oh, there they were. Okay, you can pause the video and check that out. Okay, dokie. Okay, so it's 1 minus cosine of x. This is all over divided by, where's the divided by sign? Divided by, whoops. Okay, that means I'm going to have to put this whole thing in parentheses. I think my computer is kind of getting laggy now because of my recording software. Dang it, come on, come on, come on. Oh, okay, and then this one will be close parentheses, I think. Okay. We're going to divide this by x squared. Now I know you can kind of see what the limit's approaching. Okay, whoa, okay. As x goes out to infinity. But let's look at these two other components that we have in the equation. Here, I also have 2 over x squared. So graph that and see what happens. 2 divided by x squared. Okay, and then the other guy on the right-hand side, what was that value going to be? Just 0. Hopefully you're going to see what squeeze theorem actually means now. So let's see if I can color code this. I don't know why this isn't color coding. Oh, so I got to put y is equal to 0 here. Y is equal to 0. Okay, so that's in green. Okay, so look at these color coded functions really quick. So blue is 2 over x squared. Okay, the red is our main person that we're looking at. That's ours. And y equals 0 is on the right-hand side of what is happening as we're approaching infinity to these graphs. What do you guys notice? In fact, it looks like they're kind of coalescing, right? But if you pay close attention to our main guy, which is in red, does he ever cross beyond the blue line or the green line? Do you notice that? Do you see it? I know there's a hint of red right there if we zoom in. Does it ever actually cross the green or the blue? Nah. In fact, it's being sandwiched. Or in other words, it's being squeezed, right? So here, I don't even need to visualize that. I gave you a visualization. You might not even have that tool available to you. But what you can do is you can take the limit of 2 over x squared as x approaches infinity. 1 minus the cosine of x. Oh, that's the limit as well. You're taking the limit of that. You're taking the limit of... This is sort of a dead giveaway here. but this is the limit of 0 as x approaches infinity. This, I know I can't plug in infinity. It just won't make any sense, okay? But these two out here, can you substitute in that conceptual weird infinity value? If I have 2 over infinity, or a huge quantity, what does that roughly equal? If you're dividing 2, a solid number, by an enormously large number. B, I saw Sean, he mouthed 0, right? We still don't know what the limit is of this guy. I don't know what the limit is, Mr. Wee, all right? X approaches infinity. And I told you before, the limit of the constant is just the constant, right? In this case, it would be what? What that's telling me, the squeeze theorem, is if these guys are both approaching 0, then what the heck do you think this is going to eventually approach? 0 as well, okay? Because it's being sandwiched. It's got nowhere to go, okay? So all you really did is you made this guy stuck in a situation where he was stuck between 2 functions that I could take the limit of. And then I could just say by conclusion, if these limits I can figure out are like 1 and 2, then maybe this limit should be 1.5, okay? So this is a technique that you can use, right? It looks really hard because I took like 50 minutes to explain this, but it's a lot easier said, or it's a lot easier done than said, okay? All right, well, I would like you guys to try one, but guess what? We don't have time. So there's definitely going to be like some other videos too, okay? So I'm thinking probably about 20 more minutes of content. Otherwise, you guys are good to go. I'm so sorry. Please do that practice test that's on your cover sheet. There's a link on it, okay? And practice for your exam for next week. If you have any questions, come and see me for tutoring this week and next week, okay? You guys have a great day.